Welcome to our demo of the ACF plugin. Today we will be looking at a speed comparison between FM scripts calculation and ACF plugin scripts. For some time since I saw published a speed comparison of FM engine and JavaScript functions in strong favor of the JavaScript functions. How is this concerning ACF functions doing the same? It was no details about the implementation, only the timing of the different solutions. It was about finding all the prime numbers from 1 to 50,000. So I made an algorithm for doing exactly that. How do we present the result? It could be as a single long list of prime numbers, but more appropriate would be to have it as an Excel spreadsheet. We want 10 columns and as many rows as needed. Now, Excel isn't an easy structure to work with programmatically. We will work with EXCEL-XML format. This format is somewhat comprehensive, but the example we are about to present makes this quite easy. We have made an EXCEL-XML lib that is free for you to use.
Here is an example of how to implement the calculation of prime numbers. We want an Excel spreadsheet containing all the prime numbers up to a given value given as a parameter to the function. There are 3 functions in this example. One is to determine if a given number is prime or not. Let us look at this function. We have called it checkIfPrime3. The variable n is the number. First, we see if it's less or equal to 3. Then we test if it is less or equal to 1. As 0 and 1 are not prime numbers, we return false. Otherwise, if it's 2 or 3, we return true as those are prime numbers. Then we check modulo 2 or 3 is 0, then we know it is not a prime, and return false. If we have come so far and not returned in any of the above tests, we take the square root of n, and loops until the square root value. We start with 5 as this is the lowest value that remains to check and loop each 6th number. If modulo n in the counter I is 0, or modulo n in counter 2 is 0, then we know it's not a prime. We return false not checking any further. If we have come through all the checks, we know it is a prime, so we return true. Then the next function getPrimeNumbers3 loops through all the numbers from 2 and up to the max value given as a parameter. Inside the loop, we check using the above function if it's prime or not. If it is, we add it to an array called primes that we return in the end. Finally, we have the start function we have called EXCEL-Test1. This function shall create the Excel spreadsheet. We use an ACF library called EXCEL-XML with functions to create the XML structural parts of the spreadsheet. First, we call it getPrimeNumbers3 to obtain an array of the prime numbers to include in the sheet. We declare an XML type variable called Excel that will contain the Excel spreadsheet. We build the XML structure using this lib and add some standard attributes to the elements. We make an array of columns, containing the column width we want for each column. We loop through this array, building the column declarations in the spreadsheet. Then we create an array with all the column headings. We add some heading rows to our spreadsheet. Then we add a row for the headings, looping through the array of headings. We want 10 columns, so we run through the prime number array we obtained above, in step of 10. Inside we loop 0 to 9 in an inner for loop. This will be for each column. The sum of the loop counters will be the index in the prime number table. If the index fits in the table, we add a column to our row. After the inner loop, we add the row to the Excel table. After this loop, need to define the number of rows we have made, then create a file name and path for our spreadsheet, and save the XML to the file. Then we are done. Let us test the functions and see how they perform. We are using a developer tool that makes up a single FileMaker table we use during development and testing. It is made to be an easy drop-in to any target application or run standalone. We have already loaded the Excel lib ACF package, and this package here contains our example. We have tabs for the source, a console to receive output from print statements in our code, the binary is a base 64 encoded text, our prototypes, and finally a test tab that lets us test our functions with various parameters. We have the name of the function to test and THRE fields for parameters. Then 4 buttons to call with it with 0, 1, 2, or 3 parameters. We have a big field for the result from the function, and another for the console output while we test. Then we have our test function called EXCEL-Test1, we want all prime numbers below 50,000, and as the function only has one parameter, we hit the test1 par button. And then, we got our spreadsheet almost instantly. The field execution time in milliseconds shows us how fast it is, only 151 milliseconds. Let us see what the spreadsheet looks like. It is an XML file, so we just drag it over the Excel icon in the dock. The prime number calculation took only 74 milliseconds, and including the Excel spreadsheet generation we ended up with 151 milliseconds. That is fast.
How is this for a speed comparison? Well, I haven't made any FileMaker test for this, but others have done it, and I will present their result for the comparison. I found this post on the Claris community site that compares obtaining 50,000 prime numbers using a script, abortable and non-abortable, using a recursive function, and using a while loop. Those executes in the range of 270 seconds to 160 seconds. Finally, the JavaScript variant at 0, 16 seconds or 160 milliseconds. I am pretty sure none of those produced the result as an Excel spreadsheet, but the ACF functions did the calculation alone in 74 milliseconds and included the production of the Excel spreadsheet with 10 columns and over 500 lines, saved as an XML file to disk at 151 milliseconds. The test was done on a Mac Mini with Intel i7, 6-core CPU at 3.2 GHz. Let's look at the produced XML. I opened it in BBEdit instead of Excel, and here we see the structure of the file produced. It is over 6,000 lines of XML code, produced with the help of our XML Excel library, and the built-in XML data type in ACF that lets you put together a comprehensive XML with various snippets that let you focus on each node in the XML, as shown in this example. To get you started on the ACF plugin, head over to our website and buy your license. If you have any questions, need help learning ACF, or to debug some source code you have made, or need any other help, we can assist you in accomplishing your needs. We have also many examples and other tools seen in the reference manual. You find the link to our website in the description.
Thank you for watching this video.